Okay, so in this lesson, we're going to talk about the KY92 and some of the main players when it talks about the phase lock loop and some oscillations. So let's start at the beginning of where again, we're looking at the big picture, right? If we're looking at our schematic, we're looking at to see where our reference voltage is coming in, at what point the comparator or phase detector is going to do its job, and then how is it going to be, where's the divide by, right? How are we going to bring it back to the signal that we need, and where's the VCO, etc., etc. So we start at this point here. This is a crystal right here that says Y301, right? That's the crystal. It's normally like a 3.4 megahertz crystal or something in that range. Its frequency is also going to be controlled by the capacitors. I believe this is C308 and C309, along with a variable capacitor 310. So basically, this whole guy is the oscillator circuit, okay, along with that crystal. This guy, this I312, he's a divide by 2 to the power of 7, okay? So the idea here is we want this frequency here to roughly be some sort of 25 kilohertz square wave reference frequency, and that becomes this guy here. That's what this is pointing to here. He's roughly 25 kilohertz. So we got our 25 kilohertz sitting here, and that's our first signal. Now, when we talk about where the signal is going to get fed in, now we got to remember, we got to go in this whole. We'll talk about this whole divide. Now, this is, you can imagine, this is the divide by. So if that's our reference signal, this is the divide by. But first things first, let's go where the signal goes. I won't talk about this because I want to talk about the dials and adjusting the counters here. But the signal initially, so we have an out of phase lock indicator here when it's out of phase. But the more important one is I304. Why is that more important? Well, I304 goes back to the main receiver diagram, and that's this line, this lowest line right here, which if you follow, goes right here, and there's a little filter circuit right here. So there's some filtration that happens here, and then it goes into our first oscillator, our voltage controlled oscillator right here, and notice there's a varactor right there. That's CR109. Okay, that's the varactor. So first thing here, that 25 kilohertz, or sorry, whatever coming out the phase detector, the reference voltage is 25 kilohertz. Whatever's coming out that phase detector is going into this filter first, which gets some filter, and then that potential, right? So that's our filter, and it's going to bring him to some DC potential. That DC potential is going to adjust CR109 and it's going to adjust his capacitance, and that's going to tune this oscillator circuit. Now there's a combination oscillator along with a buffer. Now if you remember, buffer is just for impedance matching. So the combination at CR109 and L111 is how we tune the VCO. So this is the VCO right here. Okay, this is a buffer. The output goes through here. So once we get that frequency we want at whatever level, this is a buffer to impedance match, and then we inject it into our local oscillator right there, and that goes to that second lead of the JFET that we talked about in the receiver diagram. Okay, so that's that portion. So we've kind of wrapped up what's going on there. Now let's go back to our loop, okay? As far as the feedback path actually comes along this line right here, okay? It says this goes back to our synthesizer. So this, there's some switching that happens here, and there's some drivers. But the main idea of what's going on in this portion of the circuit is that we're, again, doing some switching, reducing the signal, trying to get it to feed back into our phase lock loop. And that comes in on where are we? Transmit enable, transmit disable. Hang on here. Sorry, it's hard to see this because of the diagram. I gotta take it out of the picture here and look at which one that is. Digital synthesizer drive. This is 306. 306. Oh, yes. Right here, sorry. Okay, so that comes back in on this line, okay? We have some switching here. Notice we just basically have a common emitter, so the signal just basically gets amplified, goes through some coupling capacitors, and then we go into this portion of the circuit. Now, this portion of the circuit, I310 and I311, is our first prescaler. Now, this is a modulus prescaler, right? So there's two stages to it, and it's a divide by 41. So right away we get a divide by 41, okay? And then from there we also get our output. We feed the clock pulse here, and we also feed returning into these circuits right here, which these here are our I believe this one is the hex counter and this is the decade counter. So we go into a modulus prescaler, then we go into a hex counter, right? And then there's the output of that hex counter comes back in and goes into our phase comparator. Now, when you adjust the dials on your panel, what you're doing is you're adjusting these dials. Okay, we have two dials. This set of dials is adjusting the startup count for our hex and our decade counter, which associate to the megahertz. That's our megahertz counters. Okay, our kilohertz, right? Because remember, this guy, he's got a range of 108 to 135 or something along those lines, frequency-wise. So our kilohertz adjustment's done through this guy. It goes through this I301 comparator and then goes off through some logic into I308, which is just a JK flip-flop, depending on the output. And the JK flip-flop is what energizes, well, you can see the Q output here, which also serves as, look at that, the clock pulse. Okay, clock pulse there, which triggers these two counters. So essentially, in a nutshell, that is the phase lock loop, right? We've covered the reference, right? So this is our reference, this is our comparator. We go over here, that's our filter, that's our VCO. Inject that into the local oscillator, gets fed back through the circuit, and then goes into our prescaler and then our other counters, right? Our decade and counters to get fed back into the phase detector, and then obviously make adjustments depending on the size of the signal. And then as we adjust the dials, we also change the counter. So when you think of those programming, so some of these counters are pre-programmed, when you think about what they're going to count to, that's set by these things here. And you saw on slide, I forget, it was slide maybe 30 something, where those wafer switches, that's what you're doing. You're setting the logic levels here to program those counters.